Well, good evening. Hope everybody had a great weekend. Hope everybody's doing well. You guys see my screen, network basics?
Yes.
Perfect. All right. So what we're going to do, we're going to start off talking about networking. We're going to look at a little bit of networking troubleshooting. So it's all going to be about networking tonight as we move toward finishing up the class on Wednesday. Learning objectives, we're going to look at a couple different pieces of addressing, MAC addresses, IP addresses. We're going to look at subnet masking, talk about DHCP, default gateway, DNS, and the DORA sequence. Those are a couple different pieces that we're going to talk through as we look at networking. We saw when we watched that little video, that funny video looked like alien video, outer space, maybe Star Wars or something of that nature. We saw the network and this data traveling across the network, and it spent quite a bit of time going through the process of addressing. It's important as we think about these networks, these nodes that are connected either on a local area network and then connected by wide area network. All of these different nodes, we have to be able to understand the difference and be able to address each of these devices, if you will. When we went through computers, we talked about the NIC, the network interface card, and if we want to get on a network, we need to have that network interface card, that NIC. And what happens is when a NIC is created, the manufacturer will actually burn in a layer 2 address, and we'll see what that layer 2 means a little bit later as we get into the OSI model. But they burn in a layer 2 address, which we call a MAC address. It is a unique address that will identifies that particular NIC from any other network interface card. Thought I heard somebody start to jump in. You guys have something?
No, I just came in. I'm sorry, I'm about to mute it.
Okay, no problem. I thought you had a question. So as we're talking about addressing, we've got different types of addressing. We've got that media access, that MAC address, and that's that hard-coded address that is assigned to a NIC, right? A network interface card. And then we also have what we're going to find out is a layer 3 address, that next layer up, an IP address. And for the most part, I think that we've all at some point in time seen an IP address. We're still going to see a lot of IP version 4 addressing, even though IP version 6 is out there. The big difference between IP version 4 and IP version 6 is just the number of bits. A IP version 4 is a 32-bit address, and you can see that the way we write this address, here's an example, 192.168.11.12. The way it's written is these 4 8-bit octets, right? And so we've got 8 bits, and then another 8 bits, another 8 bits, and another 8 bits. And if we could represent that, in binary to complete all 8 of those bits for each of these octets. And typically we won't do that, because remember when we were looking at numbering systems, we saw how challenging it was for us to identify and just write the binary ones and zeros. And so typically we'll take that number and we'll address it in decimal, but we do it in decimal in these 4 8-bit octet format. So 192.168.11.12. That's a, an IP address. And we're going to look at several different ways this IP address could be assigned. But the big thing to know about this IP address is that it is something that can change. It's something that is not necessarily assigned to that one machine. When we saw the NIC and this media access, this MAC address, that's burned into the NIC. And so it's always going to be the address of that NIC. This IP address can change. We can go in and we could statically change the IP address. And so we assign our device a particular IP address. We're going to see how an IP address can be requested and received. And, that once we go through that process can change an IP address. And so the point is this IP address can change per device, right? I'll get one and I'll have a lease on it for a certain amount of time, or, I can assign it as a static IP address, but I can change it. The MAC address stays with the NIC, right? So you've got that hard-coded address that's burned in by the manufacturer, and it's going to stay with the NIC. The only way to change that MAC address is to change the NIC, right? And then we also got what we talk about in terms of subnet mask. This is a 32-bit address that basically what we do is we're going to use this subnet mask to pull apart the portion of this address, so this IP address, the portion that is the network and the portion that is the host. For example, this 192.168.11.12, what we're going to find out is typically, because of the range of this address, the first 3 octets are going to represent the network. This last octet is going to represent the host. And so that would mean that, if we change this 192.168.11.13, that is another host on the same network, on the 192.168.11 network. So this could be dot, 10, it could be dot 13, dot 15, dot 240, dot, whatever you want it to be, up to the point of, maximum here would be 255. We typically don't use that address. We'll find out that's got a special association. So really up to 254 would be a host on the 192.168.11.12. If we change one of the first 3 octets, and this is what we're talking about typical, and we'll look at this subnet mask and we'll see exactly how this works. But if we change one of these first 3 octets, so instead of, let's say we change this to 192.168.15.12, well, now that's a unique host, a different host on a different network. If this was the dot 15 and this 3rd octet represents the network, that's on a completely different network. And you can think of a lot about, if you, for example, your street address, you and your neighbor have the same street address because you're on the same street. So you can think about these first 3 octets as being the street, and then you've got a different mailbox address. Well, that could be that last octet. It's a different host on the same street, right? But we have this subnet mask that when we look at the subnet mask, it will clearly identify what is network and what is host, right? And so here's a closer look at that. Here's what we have here. We're talking about a class A, B, and C IP addresses. Class A addresses 0 to 126 can have 128 different networks, can have 2 to the 24, 16 million users. So if you just look at this graphic over to the right, you can see basically what's happening is we're using the first 8 bits as my network. So that is identifying the network. The other 3 octets are representing hosts. So this means that we have, fewer of these networks. When we think about across the entire span of how many of these large networks I could have, we have fewer of those because we're only representing them with 8 bits. However, on each one of those networks, you can see I've got a huge number of bits representing host. I've got 3 bits, 3 octets, so 24 bits that represent unique users or hosts. So it's a very large network. You look at the default subnet mask. The default subnet mask is 255.0.0.0. Now, 255, if we went back and we thought about binary and how we represent binary in how we represent 255 in binary, 255 is 8 ones, right? Remember, we go through the process of adding up all of the values. So all of the ones, I would get 255. And what that says is that I'm using all the bits in this first octet. Everywhere I've got ones, that's going to represent my network. And so I'm using all the bits in this first octet. So these first 8 bits represent my network. The subnet mask tells me that all the bits where I have zeros represent hosts. And so these other 3 octets, these other 24 bits are going to represent hosts on the network. So that's a Class A IP address. Next there, these are IP version 4. Class B, you can see now if you take a look at the subnet mask 255.255, so both of these first 2 octets are all ones. That means that all of the first 2 octets are going to represent network. So these first 2 octets are my network. And then the last 2 octets are going to represent hosts. Now, what that means is I've got more bits that are representing networks. So I could have more of those bits or more of those networks. But on each individual network, I'm going to have fewer hosts than I had before. Still a lot of hosts, but I'm going to have fewer than I had before, because instead of having 24 bits as I did in the Class A representing host, now I've got 16 bits that are going to represent unique hosts on any given network. And so you can have 16,000 different networks. 2 to the 16, this is 16 bits, 65,000 different users. If we look at Class C IP addresses, now we've gone the opposite direction of Class A. We've got our subnet mask of 255.255.255.0. That means the first 3 octets are all ones. Those first 3 octets all represent the network. And then the last 8 bits are the hosts. So it says we can have 2 million different networks. And we can have 2 to the 8 because we got 8-bit, 256 users. Now, here's the thing. We've got public addresses, and then we've also got private addresses. And if you think about these number of users and small networks, it'd be easy to think, well, wait a minute, if I'm going to have to think about across the entire internet, this could be a problem. Well, keep in mind that a large portion of your network typically is behind your firewall. And, really, you only need typically just a few public addresses to do everything that you need to do. If you've got a small LAN, if you've got a LAN that has, let's say you've got a web server that you want people to be able to hit, and you've got your gateway that your traffic needs to be able to get to and through, and so you get, when you go and you're looking at your network, you see a very few number of public addresses, maybe only one. And then inside of your LAN, you're going to see some addresses that some addressing that is similar from network to network to network. If we were looking at each other's IP addressing schemes, we'd probably see some IP addresses that look very similar because they're using private networks inside, right? For example, in our example, we had this notion of 192.168. Go back to this 192.168.11.12. Well, that is a private Class C address, right? It's going to be 192, fall into that range. And so when you see a lot of those devices, when they come in and you have let's say you've got purchase a router, it's a plug and play, and you connect your network up, and then you start going and looking at your addressing, there's a great chance you're going to see some of those 192.168 numbers, because they are private addresses. They're not addresses that are going out on the network. And the reason I make that point is because when you're thinking about this addressing, we're not so concerned about me having the same internal address on my laptop that someone else from a different network has, because we both have a public address on the outside that we're going to be able to share. Let me see if I can make some sense out of that. It would be the equivalent of, let's say you decided that with the 4, 5, 3, however many people live in your home, that you decided you were going to give them a number as opposed to just looking at their name. And so you would use that number internally to determine whether who gets the mail, right? When the mail arrives, you all have the same street address. You all have the same network address. But when the mail arrives, you can take a look at that number and differentiate between who it belongs to at that particular house. You can look at the name, or if in this scenario, if we gave it a number, you could look at the number 1, 2, 3, 4. Well, that same numbering system might also be, the house down on the other side of town, where they also have 1, 2, 3, or 4 for internal addressing. But it doesn't matter, because it's the external addressing, that street address, that is going to make sure that that envelope gets to the right place before those other private addresses even come into play. And so that's what's happening here, is we've got some IP addressing that may look very familiar. And if you begin to think about, well, how is it possible that we can get away with having addresses that are the same on the inside of a LAN, and on a different LAN, the addressing looks very similar? Well, it's because they've got that public network in between, and that public addressing that is really telling the difference, and making sure that those those packets are routed to the correct public address before it's sent to the private address inside. Now, what this is showing you is some of the process of what we're going to call ANDing the IP address. In essence, this is what we're trying to determine what is the network address. And if we did it from a binary standpoint, we took our IP address, and so this is our 4 8-bit octets. If we did the math on this, and remember, it's just our base to the 0, to the 1, to the 2. So this is 1, 2, 4, 8, 16, 32, 64, and 128. So I'd add up my 1, so I get 128 plus 64, which is going to be my 192. So that's all we're doing, is we're converting this decimal number, these 4 8-bit octets, into our binary equivalent, and then writing it in this 8-bit octet format. And so you can see this is 168, this is 11, and this is 12. And so that's our network address written in binary ones and zeros, 192.168.11.12. And then we have our subnet mask. We said that our subnet mask was 255.255.255.0. That's the standard subnet mask for a Class C address. I'm going to do the conversion to binary. 255 is all ones. So I have all ones, I have all ones, I have all ones, and then the last octet is 0. So I've got all zeros. And all this does is it allows basically all the bits that are ANDed with ones just fall through, and I get the exact same thing. And then everything that's ANDed with zeros, I'm going to get 0. And what it tells me is that this host 192.168.11.12, based on this network address, lives on the 192.168.11 network, right? And so you can see, you see what's happening here. And once you see it once, you kind of think, okay, well, I've got it. Really, I don't need to go back to that anymore. I don't need to go through this process, because everything falls through. You see all of my ones, everything goes through. And so all the networking bits of the first 3 octets, I'm just going to write those down. I'm going to copy those down. So if I've got 255, 255, 255, then those first 3 octets, I can just don't have to worry about converting them. I know that that's all ones. I'm going to write that down as my network is 192.168.11.0. That's my network address. That would be the major network address for that would have this host. Like I said, any changes here on this last octet, you can see based on this subnet mask, if I change that last octet, all I'm doing is changing the host address on this same network. So .12, .13, .15, 128, .240, whatever it may be, anything, the highest it can go is 255. Typically 255 is what we call a broadcast address. And so we won't address a host at 255. So the largest I could go would be 254, right? Sometimes they like to ask about, how many host addresses you could have on this particular network. Well, you can do the math in terms of 2 to the 8th power, and then we also will take out 2 addresses. One is 192.168.11.0. We're not going to assign this .0 to a host, because this is our major network address. So we won't say that's a host. We won't give out .0, and then we won't give out .255, because that's what was going to be our broadcast address. In other words, when we want to send out a message to the entire 192.168.11 network, we'll send it out broadcast, and they'll all review it. And so there's those 2 addresses that we'll stay away from. Everything else from .1 to .254 is fair game. Now, when we're talking about those IP addresses, There's a couple different things, a couple different ways we can get an IP address on our machine. Right, we can go in and statically assign an IP address, which means that it would not change. It will be the same IP address, day in, day out. But if you've got a network that has, and you start thinking about the number of hosts that we've been talking about, some up toward, could be hundreds, could be thousands of hosts. And so if you're having to maintain that network, it's one thing if you've got one machine at home, but if you're trying to maintain, a network with hundreds or thousands of hosts, the last thing you want to do is have to go out and statically assign these devices and try to keep track of all of these devices. Now, you may statically assign some of the devices. For example, your printers, your network printers. You may want to have a addressing scheme so that you can assign network printer static IP addresses so that you know where it's supposed to be. Right? You already know, you don't have to worry about the address changing and then trying to print to a different address. And so you may want to go in and assign those static IP addresses. But for hosts that are just using the network and really they don't have to worry about being at a particular address, we're going to do a process that's called DHCP. So this dynamic host configuration protocol, this DHCP server, we're going to utilize that to assign some of these IP addresses. So basically, this process, these 4 steps, if I have a DHCP server, and so I will, assign a DHCP server to my network. And when I boot up my machine, it goes through this process of discovery, offer, request, and acknowledge. And so this DHCP discovery, the booting computer sends out a discovery broadcast on the network. So it sends it out to, just anybody who's listening, asking a DHCP for an IP address. It's basically saying, hey, I'm looking for an IP address. I need an IP address. The DHCP server will respond. It's going to once again broadcast out, because keep in mind, the host that's requesting this IP address doesn't have an IP address yet. And so it can't just send it directly to that one machine. And so it broadcasts back out an offer of an IP address. The DHCP request, the computer responds with a broadcast requesting to use. And then finally, a DHCP acknowledgement. The DHCP server will check to see if the address is still available. And if it is, it will send a DHCP acknowledge to the computer to use that address, and will include the date, time the address was obtained, as well as other information. So basically what happens is you've got, this server that says, or the host machine comes on, I need an IP address, broadcasts that out, basically yells that across the network. The offer of, I've got an available address, how about this one? The request, the computer once again says, hey, let me use it. And then the DHCP server will check it to verify that it's still available, because you could have multiple hosts that are coming on the network pretty close to the same time, and they may be in contention for some of those IP addresses. And so you may have an IP address that went out across the network, and multiple hosts saw that. One host is going to respond faster than the other, and they'll get to use the original IP address. If the IP address is used at that time, then it'll send out it'll go through the process again to once again look for an available IP address and go through the process until an acknowledgement is received from the DHCP server that yes, this DHCP or this IP address is valid and good to go. So every time you boot up your machine, if you don't have a static IP address, it's going through that process. Now, what you may find is that it seems like you always have the same IP address. You get a lease for an IP address for an extended period of time, and then even when it's renewed, it's released and renewed, you may get that same IP address right back. That's not uncommon, especially if you've got a small number of hosts on your network. Other important network devices, addresses, this default gateway. So the default gateway is the IP address of network traffic that's leaving and entering your network. Basically, when you send out a request, for traffic to go to some location, the first thing it's going to do is it's going to look at that network address, and it's going to determine, is that network local or somewhere else? If it doesn't know where that network is, it's not, obviously it's not a local network, then it's going to send that packet to the default gateway. It's basically going to say, hey, I don't know where it is from here, but I know it's got to be in that direction. It's almost like, once again, looking at, thinking about your neighborhood. If you've got mail that's leaving your neighborhood, it's not going to go to your neighbor. Well, then typically there is a great way to send it out. There's a direction to send that mail, and eventually it'll get to the right location. Doesn't mean you need to know the entire path for that next stop, for that default gateway. You just need to know that it needs to go out of your local network. And so that's what you have, is this default gateway, this IP address of, next stop here. Send it to the default gateway, and from there, the networking devices, routers will take over and begin to send it closer and closer to the destination network. A DNS server, when we talked about numbering systems and when we were looking at binary and seeing how difficult it could be to operate with all the ones and zeros, we said, that's just not easy to manage when you get to large numbers. Well, same thing is true with numbers and us and locations. It's much easier for us to remember a name of a website than it is to remember the address, right? It's much easier for us to remember names than it is numbers in general. And so when we look at this DNS server, what this server will do is it'll take the names that we know to be our popular websites. I want to go to Yahoo or Google or whatever it may be. I can remember the website name, but I don't know the website address. Now there's an IP address assigned to that website, and this DNS server will go through the process of matching up the name with the IP address. Right? This is the phone book, if you will. Right. So you give me a name, I'll give you the number. And so the DNS server, you type in your URL, and it will immediately send that to the DNS server. So the DNS server can turn that into an address, an IP address, and then begin to route that traffic to the proper destination. Home routers, access points, it's become easier and easier to set up home networks. Everything pretty much now is plug and play. I will say at one point, things were so easy that there was a real issue with security, because you had these routers that, you plug and play, you plug them in, you plug your network in, and boom, away you go. but very few people took the next step of properly securing the network and even going in and changing the passwords, changing the addressing. And so, you would see, a wireless network that would have, still the default SSID. And if you knew the default SSID and that wasn't changed, then typically the IP addressing wasn't changed either. And so you could go to that IP address. And if those two weren't changed, there's a good chance that they didn't change the default password either. And so you could actually, by looking at the SSID, go to the URL, the IP address and the default IP address, and then log in with the control password and make changes to the network. People have gotten a little better at securing their networks. I think access points have put a little bit more security in place than there used to be. There's certainly menus that kind of drive turning on some of that security, and so it's better than it used to be, but it's still not perfect. Okay, this is just giving you a kind of a breakdown on what's taking place. Networking similar to the post office. Mail a letter, you have a return address, a destination address, of course a stamp. Mailman picks up the letter, takes it to the post office. Post office sorts the mail by looking at the zip code of the destination and forwards to the post office of the destination zip code. This post office may sort it by zip +4, large service area. Then it's given to the local postal worker for delivery. Postal worker looks at the street address and puts the letter in your mailbox. You go to the mailbox and get your mail. And so we're all very familiar with that process, very similar to what's taking place with what we saw on, the little video that we had a couple weeks ago. Every packet that leaves your computer has a source address and a destination address for the sending computer and receiving computer. They have those two separate addresses. They contain a MAC address, and that's the physical address at the NIC, and an IP address of the computer they came from, source, and the computer server they're going to, the destination. They may go through several routers before reaching their destination, and each router looks at the destination network address to determine which port to forward the packet to. Upon arriving at your home router or the destination router, it is broadcast to all computers on the network, and each computer looks at the return IP address, and only the computer that has a matching address, a host address, allows the packet into the computer. All other computers discard the packet. The web page you requested may require many packets before it can be displayed on your monitor. So all of this is happening at a very, very fast pace. It's just like I said, it's there's a little bit more than that. It's more involved than just that, but in essence, that's kind of what's taking place. Somebody have a question? Looking at some cabling, here we have 568A and a 568B. These are identified. These are standard patch cables. IEEE. If you look at the visual down below, you can see the difference in the 568A and the 568B in terms of the color code. When we think about this network data, the way it's been transmitted. You'll hear a couple different terms for what's being transmitted across the network. You may hear it referred to as a packet. And so here what we have is this packet below that has the data. You can see it's got the addressing, it's got a preamble, and then it's also got this FCS, which is responsible for making sure that the packet that is received is the packet that was sent. We saw in the video how sometimes things happen to some of those packets as they travel across the network. Sometimes we have collisions. It's a lot of traffic on the network, and so this FCS will verify by doing some of the calculation based on the size of the packet and information that was received, just to make sure that the calculation comes out the same at the destination as it did the sender, the source. That way you received the full packet or not. And you can see a little bit about what each area does. A preamble provides clock synchronization for the network devices transmitting the packet, so make sure that things are synchronized. We have that destination address, both IP and MAC, source address, IP and MAC, and then once again talking about that beyond the data, but the FCS, talking about the function to make sure that the packet received matches the packet that was sent. This arithmetic sum of the information contained in the packet. If something doesn't match, then it knows that there was a problem with the packet and it will be retransmitted. Depending on kind of what level of the OSI model we're talking about, and we'll take a look at the OSI model in just a few slides, I think. Packets, typically we're talking about layer 3. Frames, you hear that more at layer 2. Block cells or segments at other layers. And so you may hear any of those different pieces when we're talking about this information that's traveling across the network. I would say it's pretty safe to bet that you're going to hear packets or even frames most often. Talking about bit framing, encapsulation of data into packets of frames is called bit framing, not to be confused with bit streaming. And basically what it's talking about is how they put the packet together, the bits together again. Remember, all of this data is represented as bits. And then we're going to dive into the OSI model. Before we dive into the OSI model, we're at a quarter till. So let's take a break and let's come back at the top of the hour. So let's come back at 8 o'clock your time, 9 o'clock my time. All right. See you in a few.
Okay, thank you.
Mm-hmm. Okay, let's take a look at the OSI model. Basically, this OSI model was adopted in 1984 by the International Standards Organization. You know, there's a couple different things that it does, and you know, one thing that it does is really aids in education. So when we talk about the whole process of encapsulation, de-encapsulation, it helps us kind of define what that process looks like by having these layers, this understanding, you know, this standard that we go by. It also helps in terms of interoperability, making sure that the needs are met at those different layers. And when we're looking at connecting devices, you know, making sure that those devices can agree and connect and coexist on a network, right? And so when we're talking about this OSI model, it kind of does those things. You know, effectively describes computer packet transfer by using various layers, 7 layers, with each layer relying on the next lower layer to perform functions. Each level provides services to the next higher layer. Changes made in one layer do not need changes in another layer. OSI model can be modified, but only enhanced, never degraded. Right, and so it's the standard that we want to kind of stick to. And like I said, those notions of understanding of the encapsulation, de-encapsulation process, but then also interoperability are you know, kind of aided by this OSI model. I want to jump ahead a couple slides, and then we're going to come back to this slide just so you get a picture first. Well, okay, so here's what we're going to talk about. We're going to go through these layers. This is the OSI model on the left. This is a TCP IP model that's on the right. We'll talk about it in a little bit, but we're going to focus on this OSI model. And we're going to start with this top layer, and we're going to work our way down and you know, get to the physical layer. Now, if you notice, just by looking at the top and the bottom, here we are, network process to application. So this is basically closest to the end user, and then we get down to here we have our media, our signal, you know, binary transmission, you know, the physical, the actual media connection, you know, whatever cable it may be, or wireless, or whatever it may be. So you can see we're going from user, we're encapsulating this information layer by layer by layer, and then we're going to send it over the physical medium as bits, and it's going to go to some destination, right? And on the receiving side, this packet would be received, and it is going to then be stripped away layer by layer until we get to the data that's inside this, you know, whatever was placed in by the application, right? And so we're going to go all the way down, taking this, encapsulating it, you know, putting it in, you know, the different addressing pieces and other items that need to be included in this packet. Till it gets to the bits, it goes across the medium, and then those bits are you know, once they arrive at the address, that addressing begins to be stripped away, and it keeps getting passed up until we're left with nothing but the data that we had to start off with. And so in reality, while we're going encapsulation down from layer 7 all the way to you know, our physical layer, across the network, and then at the receiving, we're going to go de-encapsulation back up to application layer, but also in some ways have communication layer by layer, right? There's information that is sent from the, you know, the physical layer that's going to be received by the physical layer. The way it's encapsulated and decapsulated, this data link information is going to be read by layer 2 at the receiver. Network layer is going to be connected to the network layer of the receiver. It just goes down and then back up through that process. And so just want you to kind of see that model, kind of get a visual as we go through each one of these layers, these 7 layers, and talk a little bit about each layer. So that top layer, that application layer, right? So that's the layer that is the closest to the end user. Right? So that's the layer that is the closest that you are connected to as you are on your your laptop. The layer where application programs interact with the network resources, your browsers, email, other network applications. That's layer 7. You're gonna do whatever you do in terms of your input into the device that cause this network to begin, this process of encapsulation to begin, right? Presentation layer, layer 6. It's how the data is presented. We got ASCII, how it's, in encryption and compression are also at this layer. So if we want to include encryption and compression. So how the data that was generated at the application layer, how is it going to be presented moving forward? Layer 5, the session layer, establishes and maintains communication and data exchange between network nodes. Right? So it's agreeing on the session terms, if you will. Right? What are the requirements? What are the the key pieces of connecting that session sender to receiver? Transport layer divides large messages into smaller segments called PDUs. Ensures the packets are transmitted without errors. So it does some of the error checking. Establish connection between network devices, acknowledging the receipt of packets and resending of packets that are not received or corrupted. As we're looking at some of that data validation to make sure that it is correct. And keep in mind, we start an application, we're moving down transport layer, we're doing some of that error checking there. It goes all the way to the physical layer, it goes across, and then it's going to go back up and look at that transport layer. It's going to look at these calculations that were done. And it doesn't make any sense to wait to the very end to do some of those calculations. If the packet has been corrupted, you want to do it, some of that calculation at the transport layer so that another packet can be resent, and that's going to speed that process up even more. Network layer, that's the layer 3. That's where the IP addressing lives. So it provides routing information for packets. Routers use this information to determine the best port to forward this packet to, where it needs to go, puts it into an IP packet. That's our IP addressing. So our IP version 4 could be IP version 6 addressing, and it's going to look at that network and determine the closest or best path to that network. If it doesn't know where that network is, which means that it's not local, it's going to send it to default gateway. So it's going to send it to the next hop, which will get it closer to this unknown network. The data link layer, layer 2. Layer 2 actually has 2 sub layers, if you will. It's got MAC and the LLC, which is a little confusing, but they just divide that up as well. Data link layer provides error detection. Once again, some more error detection, correction to ensure the data sent is the same as the data received. We're doing that first check here. This is the first layer beyond the electrical signals on the medium. If it's say it's a cable, those electrical signals that represent the ones and zeros, that information. And so we are just now layer 2, and it's going to go ahead and do an error detection to see if what we've received is corrupted or not. If it's corrupted, then retransmission is going to take place. Like I said, this data link layer is divided into the media access control and the logical link control. The MAC sublayer provides flow control, multiplexing. And then the LLC, which this is where it gets a little confusing in terms of some of the naming. The sublayer, the LLC, is also where that MAC address lives, right? So the ones and zeros that are going to determine that, that addressing information. And remember that MAC address, that's the address that is hard coded, burned into our NIC, right? And so you got at this data link layer, you've got your NIC that is existing. One of the things that you do often in terms of think about some of this terminology, data link layer. Well, if you're looking at your NIC, you usually have a data link indication, that little LED that shows you the traffic as it's coming across should be flashing. And so it helps you just remember that when we're talking about layer 2, we're talking about that's that NIC and that burned in MAC address at the data link layer. And then all the way down to the physical layer. Now this is your medium, which could be cables, could be fiber optic, could be wireless, whatever is being used to transmit the message over, right? This would be the physical layer where we have a physical connection to the network and obviously a physical connection on the other end to the receiving host. A couple of acronyms that you could use, OSI model, if you're trying to remember those. Some people use this, please do not throw sausage pizza away. You can see each one of those stands for physical, data link, network, transport, session, presentation, application. You can use an acronym, but I'll say that typically, once you start kind of putting a couple of those in place, it becomes fairly easy to remember the rest of them. You already know the physical is where the medium is, the data links where the MAC is, the network is where the IP address is, the transport is where we're going to do some of that error checking and going to break it into smaller segments. And then, the application, the end user, the application. And so really, that session and presentation, just remember, kind of those two, typically you can recreate those layers 1 through 7, or if you've got 7 through 1, if you're going the opposite direction, application through physical. All people seem to need data processing. Each one of those acronyms will work, or you could come up with your own acronym as well to help remember those layers. Typically, they love to ask questions about those layers on some on the TKT, but if you ever decide you're going to do any type of other certification, Net Plus or something like that, they love to ask about the different layers of the OSI model and making sure that you can list and talk briefly about each one of those. Now, we looked at this graph already, and we've seen what the OSI model is all about. The TCPI model really accomplishes the same thing. It's fewer layers. Basically, what happens is they take the application layer and they expand it out, and everything is included. The session, presentation, and application of the OSI model. All of this data now becomes the application layer of the TCP IP model. Transport, still same functionality there. A little bit can be a little tricky. The network, where the IP addressing exists in the OSI model is now the internet layer. This internet layer is, once again, the IP addressing, so same functionality there. And then data link and physical, where I've got my MAC addressing, that hard-coded addressing, along with the physical medium. Now all of that is included in the network access. And so TCP/IP, they just use fewer layers, but once you can kind of draw these comparisons, top three are in application, bottom two are in network, the middle two are a one-for-one. The process of encapsulation, so going from this data all the way down to these binary bits, or de-encapsulation going the other way, is still the same process. It's still putting those headers and servicing those different layers. All right, so we talked about MAC addressing, IP addressing, subnet mask, the DORA process. Let's see, let's answer a few questions. What is the MAC address? Anybody remember what that MAC address was?
It's the address given to you from the actual, like a device itself.
Okay. Where does that MAC address, where does it live? Where does it exist?
I want to say the chip, but it's inside the, I guess like a chip itself, the card itself.
Yeah. What do we call that card?
The NIC card.
NIC card. Absolutely. Yeah, absolutely. Very good. Yep. So it's on the network interface card. It's that manufacturer given and burned in address. And part of that unique address identifies the manufacturer as well. How about an IP address? What is an IP address?
That's the address given. That is the address given to you from the router. It starts usually from the host from 0 to 254.
Okay. Yep. And so it's, could be given to you from a DHCP server, could be statically assigned. It's that layer 3 address. Yeah, absolutely. All right. 32-bit. What's the purpose of a subnet mask?
To mask the subnet.
Good try. Now keep in mind, so our IP address, it identifies the entire address of not only the network, but also the host on the network. And so how do we know what of those, 32 bits, how do we know which ones represent network and which one represent hosts?
Well, the subnet is the 255.255 and so on, but
Yep.
That's the only way I know the difference on it.
Yeah. So what happens is that subnet mask identifies the portion of the address that represents the network. Okay. And so let me just quickly, if I don't make anybody car sick. So here, remember when we're looking at our subnet mask, those 255s, so all of those ones, they identify the part of the IP address that represents the network, right? And so I had all ones in this first octet, and so all of those bits represent the network. 192 represents the network. All the bits here, 168. All the bits here, because they're all ones, 11. None of the bits here. So that subnet mask of 255, 255, 2550, what it does for me is it tells me of this 192, 168, 11, 12, what bits are the network, the first 3 octets here, and which bits are the host bits, these last 8. Now, what we talked about were the default subnet mask. right? And so it seems pretty clear, and you're probably thinking, well, wait a minute, shouldn't it always be the same? Keep in mind what I could do. Now, we don't get into this really in this course just because it's not a function of the TKT, but what I could do is borrow some of these bits. Let's say that I wanted more networks with fewer bits. I can borrow some of these bits and create a different subnet mask, which would then identify that I can use some of these bits as my network as well, right? I could give you, for example, a subnet mask of 255.255.255.240, which would say, okay, I want the first 4 bits of this last octet to also represent the network. Now, I give you that additional information, not to confuse you, just to let you know that this subnet mask, it's all about identifying which bits represent the network and which bits represent host. Anywhere I have 1s, those are network bits. Anywhere I have 0s, those are host bits, right? So that's what our subnet mask is going to do for us, is identify network and hosts. The DHCP server, that's the server that's going to give us the IP address. And then what is that default gateway?
It's the address given to you from the modem.
Okay. Usually, yeah, you're right. It's basically the address that's going to be given to you. And what it says is, if it doesn't exist locally, then that means it's not here. And so here's your next step. Send everything to this default gateway. It needs to go out, right? It needs to leave our local network. All right. What's that?
Everyone, if you're having problems with network connections, for instance, your browser's not working, or you can't print, or maybe when you try to access files on the file server, it's not going through. So maybe you're seeing screens like this when you open up your internet browser. This video will show you how to use the command prompt, which is this black box back here. Will show you how to troubleshoot, isolate, and even solve network connection issues. So I'm going to show you some things using some commands inside this black box, but it has nothing to do with programming. This is aimed at the average computer user who wants to try to identify problems themselves, possibly saving the need to have to call an expensive IT person to come remedy the problem. Okay, so let's get started. All right, so let's get this command prompt open so we can learn some basic things about our computer. For Windows 7, you would hit the little start button and then you would type in CMD. What you want is this little icon right here, that little black box with the letter C in it. For those of you who remember the days when we ran computers on the DOS operating system, this is pretty much the same thing. Anyway, if you're on XP or if you're on Windows 10, just use either, like on XP, you can do start run and then type in CMD, or you on Windows 10, I think in that little box where it says ask me anything, you can type in CMD and find it that way. So once we've got this box open, let's see what the status of our network adapter is. Let's see if we're even connected. We'll use a command called ipconfig, IPCONFIG. That's all one word, and then hit enter. Now, right off the bat, I know I'm not going to get far because it shows media disconnected. So this could be a couple of things. If you're hardwired, meaning that you have a wire, network wire from the wall that physically plugs into the back of your computer, it means that maybe the other end of that wire has a problem, like maybe it got plugged into the wrong port, maybe it's unplugged. Maybe the switch or the router in the back room where all these, well, the equipment is powered down. We're not going to get much further than this if we've got media disconnected. And now, if you're on Wi-Fi, it might mean that the Wi-Fi antenna is turned off, or you've become unconnected from the Wi-Fi network. And that's kind of a different ball of wax outside the scope of this. But if you remember how you connect your computer to the Wi-Fi, you need to repeat that process and then run the ipconfig command again. And what you should see here is some kind of an IP address. Now, the other thing you might see is something like this. I'm bringing this in from another computer. And that is where you see you have, you run the IP config, and you'll get an IPv4 address of 169. So what we're looking for is our IPv4 address. This is an unhealthy one. If it starts with 169.254, what that is the Windows way of telling you that the network is physically connected, meaning that the electricity is there, the wire's connected, that part's okay, but the part of the network that gives out IP addresses is not working, or we're not making connectivity with it. So this might indicate that either the router or the server that gives out these IP addresses is not working right. So what would it look like if I had a healthy connection? Well, let's see. We'll go do that next. I'll restore a healthy connection, and I'll show you what that should look like. All right, in our next example, let's say that our network connection physically is okay. And we do an IP config to see what our IP address is. We're looking for the line that says IPv4 address. See this right here? IPv4 address, ... all the way over here. I see 192.168.0.141. That's a pretty typical local area network address that's automatically given out by a router or a DHCP server. And as I throw these technical terms out, you don't really need to know what these are. It just, all that matters is I'm trying to help you with some simple ways of finding out about your connection. The other thing we'd want to know is, what is my default gateway? This is usually the address of the device we have to go through to get out to the internet. Now see here where it says default gateway, 192.168.0.1. So what I'm going to do right now is, since I know I'm connected because I've got a healthy address, in other words, it's not that 169.254 that I showed you before, and it's not media disconnected, is I'm going to ping my gateway. So ping is a command that you can use that basically sends out a test message to another device saying, are you there? Can I reach you? And so it's ping, and then the gateway address. So 192.168.0.1. So ping space 192.168.0.1. My computer is sending test messages over to the gateway, which is usually a router, and I'm getting replies back. Replies are coming back from that router. It's telling me how long the round trip time was in milliseconds. So that's good. I know I can reach my router. That's a good sign. So from a local area network perspective, I know that my computer's connected to the local area network, and I know I can talk to the router. What you might see that would be bad would be if we were pinging something and it wasn't replying, or we were getting destination unreachable. So right now I just pinged a fictitious address, and I'm getting replies back from my own network adapter saying, I can't reach that. I can't reach that address. If that's the case, then it means that you may still have a physical connection problem going to the router. If you're in a small office environment, a lot of times it could be just as simple as checking to see if the router is even powered on, or rebooting it. Or if you have a separate switch, rebooting that. The other type of bad response you might get is something like reply timed out. So either way, if you get unreachable or timed out, it means that we can't, from a network perspective, reach that routing device. So let's say we did ping the router and that was cool. So the next thing I want to know is, okay, I got to my router, but can I get outside? Can I get out to the network, to the internet? So you can do that by pinging an IP address of something that's out on the internet. Most network professionals usually do something like Google's address, which is 8.8.8.8. So ping space 8 period 8 period 8 period 8. And then you get replies. So that means, okay, great. I can reach the internet. I can reach something out on the internet. On the other hand, if I'm getting unreachables or if I'm getting reply timed out, then that means that there's something going on. Maybe my internet's down. Like even though my router's working fine, the cable company or the telephone company that supplies my internet might be down, so it might be time for a phone call. The nice thing about what we're doing here is that when you're armed with this knowledge is you can talk intelligently. I can't talk. You can talk intelligently to the people on the other end of the phone to tell them, listen, I know I can ping my router, or I know I'm getting an IP address. These things greatly reduce the amount of time that is spent troubleshooting. The last thing I want to know is, okay, great, I can reach my router, I can even reach Google, but do I have what's known as domain name resolution? That means, can I ping a domain name like yahoo.com? Because you may have the ability to ping an IP address on the internet, but if you're having what's known as a DNS problem, meaning the domain name service, it's kind of like a phone book. It allows the browser to take a name and convert it into an address. If that's not working, you can have a situation where you can ping an IP address like 88888, but not be able to ping something like yahoo.com. Like, let's suppose I did yahoo.ocm. I don't even know if that's a real domain. Let's see, ping yahoo.ocm. You see, that's not going anywhere. Okay. So that means that the domain service can't find that name. Or if you know the name is good, but it can't find it, then it means the DNS service is down. Again, if you're in a small office environment, if you can't resolve a name, that might mean it's time to reboot the router. Or it might even be time to reboot the modem that came from the cable company or from their DSL provider. Sometimes they're the same box. Sometimes your router and your DSL modem or your router and your cable modem are the same box, but sometimes they're separate. So armed with that knowledge, you should be able to try to isolate whether or not the problem is just locally on the PC or whether the problem is at the router or your ability to reach the router. And then moreover, to know that if everything's fine on your local area network, maybe there's a problem with your ISP or maybe the domain name service is having some trouble. And that domain name service could be a problem either within your local area network or outside, but more times than not, it's usually on the inside. So I hope that these commands I've showed you have given you some information to be able to kind of isolate problems yourself. If you like what I'm showing you, please give me a thumbs up or leave a comment. I'd love to hear from you.
Okay, let's take a look at network troubleshooting. And I think some of this, he kind of went over a little bit in that video, and so we'll we'll take a look at it, and then you can also do a lot of this on your own machine as well. Okay, so what are we going to do when network fails? First thing, when we don't have connectivity, when we have issues, always think simple first, right? Go as simple as possible. Things that fail more often are probably the case. Things that move fail more often. And so I would look at, that physical layer, think about the cable, think about, do you have connectivity at that layer? If you look at your NIC, do you have lights that indicate that you have connectivity? Do you have a activity light that's flashing? Those are good signs. If you don't have that, then there may be an issue. Keep in mind with networking, it may not be the issue on your end, right? And so if you've got a network card, you got a patch cable plugged in, and you don't get the data connection that you think you should, you don't have the link lights, you don't have any activity, well, it could be on the other end. You don't know what's happened with the other side, the connection on the other side of the network. And so, but, always start simple. Don't immediately jump to, the hard stuff. There's some things that just don't change that often. And there's some things that are much more likely to change, to fail. It's much more likely that a cable gets rolled over or stepped on, pulled out, versus something like a config on a router changing. So start simple. And start looking at the connection to see if you have connectivity, and then move from there. If it's lights are not indicating that you have a connection, it's always easy to try another connection, try another cable. Keep things simple. We looked at device manager when we were going through Windows. You can open up your device manager and take a look at the NIC to see if it's operating correctly. Remember that just because it says it's operating correctly doesn't necessarily mean that everything's okay. But definitely, if you have an issue indicated here, then you got problems, right? And so it's a good place to look, just to validate that things look like they should here. All right, so if I want to go to the command prompt, I can go to my search box, type in CMD for command, and it'll pull up a command prompt, and then I can go and start using the IP config with all the different switches. You can see a couple that are listed here, /all, /release, /renew, /flush DNS. All of those are available. If you do a IP config / question mark, it'll give you all the options. And so it's that's a great place to go and confirm that your configuration is what it should be. Your IP addressing looks like it should, just like you saw in the video. You can see your IP address, you can see your default gateway, your DHCP server, any of your DNS server, all of those different things. And you can kind of walk through and make some sense of, are you having problems with everything? Or are you having problems with only a few things? Is it something that is isolated? Like, for example, you can't resolve a URL. Okay, well, maybe it's the IP address of your DNS server. If you have no connectivity at all, and it's not on the physical layer, well, then maybe it's an IP addressing issue. And so you can, depending on the symptoms, you can take a look at your configuration and determine what steps to take next. All right, so we have here we're looking at our Ethernet adapter. You can see our IP addressing. our address 192.168.1.116. We know that this is a Class C address. We look at our subnet mask, and you can see what we were talking about. The first 3 octets represent our network. So this is the 192.168.1.0 network. Our host is 116 on that network. You can see that we've got a lease. We got a lease October 11, 2020, and it expires the 12th at 2020. So we have our DNS or our DHCP leases going out for 24 hours. You can see we have a default gateway of 192.168.1.1. That's the next hop for any traffic. We're not sure where to send it. Send it to 192.168.1.1. What's going to happen is that router that is on the other side of the 192.168.1 network is then going to look, and it's going to make the determination, is the address, does it need to go in? Obviously it's not if it's going to this address, or out. So it would forward it out to a destination address that's outside of your local network. Same thing here for your DHCP server. Remember, that's where you're getting your IP addressing from. It's that same router, 192.168.1.1. Obviously, this is a router that also has DHCP services built in. Our DNS server, right? Going to the same location. So you see you got a lot of information here, and you can easily use the connectivity tool ping, right? And what that's going to do is going to send out a packet and listen for that packet to come back to verify you have connectivity. If you are unable to get on the network, you're unable to, in this situation, you type in a URL, you can't get anywhere. If you ping 192.168.1.1 and it doesn't come back, then that indicates that you've got an issue there. This router may be down. Now, if you can ping 192.168.1.1, but you can't get out, then what you can do is start isolating. Okay, is it one specific network I can't get to, or is it any network outside? You can even use another tool, trace, where you can trace the packet to see where it is stopping. Which hop is it stopping? How far does it get? I think you saw this in the video, this 169.254, this automatic private IP address. If you can't do anything and you see this address 169.254, then that's an issue. You're going to have to basically release that address and get another IP address, right? And what I would try to do is release that and see if you can get your DHCP server to give you another IP address. If it does, then great. If it doesn't, then you're going to have to look at what connectivity issue you might have that's causing that 169.254 address to be held on to. One of the things you can do is ping your own default gateway, your DNS server. You go in and just type CMD in the search bar. It's going to pull up your command prompt. Then all you have to do is type ping, whatever address you want to ping, and you're going to see something that looks like this. And you're going to see this is basically 4 packets that have gone out, and then they have returned less than 1 millisecond. And so it validates the fact that yes, you have connectivity. These packets are going out and being sent back. 4 sent, 4 received, 0 lost. Now, it sometimes, depending on what you're trying to test connectivity to, you may only receive 3 packets back, and sometimes that's because when it's finding the way to the destination, it might take a little bit longer for that first packet, and that first packet might time out, and then by the time that second packet is sent, boom, it comes back, and you get 3 of the 4 maybe fine. That's not a, if you see something like that, that's not an indication that you got something wrong with your network. It's likely an indication that, like I said, that router was learning the path that first time. Let's see. So if you didn't, let's say you tried to ping your default gateway and you did not receive any replies, then obviously that indicates that you got a challenge, you got a problem there with your default gateway. Either the default gateway is wrong, or you may have entered the default gateway in incorrectly, or you've got another connectivity issue. One of the things you can do is go in and release your IP config so that you can renew it. It'll go through that door process, and which will give you your new IP address. It'll also give you a new information in terms of your DHCP server and all of your default gateway and that information as well. And so if there was an issue with that, if something changed there, you can release it, renew it, and you should be able to get connectivity that way. If you still don't have connectivity and it's nothing physical, then you could look at some other possibilities of how you might be able to test. You're taking a look at your network. Do you have connectivity inside your network? Just to verify what you can and what you can't get access to, so that you have a better understanding of the problem, and then from there, create the next, determine what you need to do next. If you could have a situation where if typically, if it's not the physical layer, as we continue moving up the OSI layer, OSI model, let's say that you jump to IP config because it's easy. Well, you could have a problem with your NIC as well. That doesn't happen a lot, but the NIC could go out. You could have an issue there. So check your IP config, but if you can't release it, renew it, and resolve the problem, then and if you're sure it's not the physical layer, then you continue looking at how you could test even layer 2. One of the things you could do is take a look at other hosts on the network. Are there other hosts that have connectivity? You do your IP config all, and it gives you all of the information, just like we saw a while ago. You can get your default gateway, your DNS server, all of that. You can ping those devices just to make sure that things work out. One of the things you can do if you're, let's say it's a DNS server issue, if you can't get to a URL because it can't resolve the URL to an IP address, then you can always use an IP address instead of the name, right? And so you could go and you could look at what is Google's IP address, external IP address, and you can put that in versus the Google www.google.com. And if it's just your DNS server, you'd be able to get there by using the IP address and not get there by using the URL, the name, because it's the problem resolving that name to an address. Just one way to check that, verify that your DNS is working or not working properly. Looking at Wi-Fi, mentioned that Wi-Fi can be a challenge, in terms of security. You can use Wi-Fi, everything that you could do with looking at your IP addressing with the regular network, you can also do with your Wi-Fi. Then also you can disable your connections. That's a common issue. You see that a lot where you've got a Wi-Fi connection that is disabled, and obviously you're not going to be able to use it if it's disabled. You could also have connectivity issues with Wi-Fi. So just the unique nature of setting up Wi-Fi in general could be something that creates a problem. I think we've all connected to plenty of wireless networks now. Just the big thing is just be careful of the wireless networks you connect to. You see more and more two-factor connectivity and two-factor authentication required for connectivity, and so those are secure networks. Some networks are less secure, and may leave you more vulnerable. So let's see. All right, so if and hopefully you can see my screen now. Basically, I just went in and did a IP config, and you can see all the information that my IP version 4 192.168.0.18 subnet mask is at 24-bit network 255.255.255.0. My default gateway, DHCP server, all of those different components, and so all of that 192.168.0.1, I can go in and I can ping all of that. Confirm that yes, it's going to come back. I can also ping. It's let's see. What happens when we're ping cheese.com? Okay, so destination port unreachable, meaning they didn't like that, right? If it's let me look up this address.
She don't even book it to you. So imagine she don't even.
And so that's an example of, instead of pinging a URL, I could ping a public IP address of a group that I know. And if it comes back, if I couldn't get there, let's say that, this is Google, I couldn't get there with Google, but I could get there with 8.8.8.8. Well, that would indicate that I had a DNS issue. My server that was trying to take the name and convert that into an address was having an issue. And so then from there, I could step to, well, I know my DNS server is 192.168, or no, here it is, 209.18.47.61. And so I could try to ping that, and 209.18.47.61. So let's see what happens when ping that. See, I'm not having a problem with mine, so I get packets returned. But if I couldn't get to Google, I couldn't ping Google, but I could ping the address, which indicates that I'm probably having a problem with DNS. And then I did this, could not ping my DNS server, then I'd want to try to find another DNS server. I'd want to go through the door process and get a handoff for another DNS server. All right. You guys used ipconfig much?
No, it's all automatic for us now.
Okay. Okay.
Hey, Mike, I've used it when we used ipconfig released and renewed.
You did?
Yes.
Good, good, good. It's a nice troubleshooting tool. It gives you a lot of information. It's a way to get a lot of information quickly. So yes, it's not a bad tool. Get back to our course. All right, so we went through networking and network troubleshooting. We're going to go through flowcharts on Wednesday, and then we're going to have a once through review on Wednesday as well. So we're going to hit some high points. We're going to go through some of the assessment questions that we haven't gone through yet and hit those and make sure that we feel comfortable. So we're going to do that on Wednesday. The flowcharts will not take a whole lot of time. So we'll do that for flowcharts will probably be about the first 35 minutes of the class. And then from there, we'll get into our kind of a review, quick review and a brief assessment. So with that being said, I'm going to go ahead and turn you guys back to the online course. It's up and running. I do have a couple of videos that I need to put up. And so I'm going to put those up now. And then, I'm going to hang right here. So if you have any questions, feel free to, just let me know what you want to talk about, what you want to work on. Otherwise, I'm going to turn you guys loose to the online class. And once again, look at those assessments and get ready for our last class on Wednesday. Sound okay?
Sounds good.
That sounds good. But on our last day of on Wednesday, is it going to be like the last day of school where we just watch videos all day?
That's right. Watch videos and we'll bring snacks and yeah, we'll have a party. Very good. All right. Well, we'll see you guys on Wednesday. I'll be here if you got any questions.
Thank you.
Absolutely. Thank you.
Recording stopped.